right, what'd you decide? Last one. All right. So the last one on this second page. Okay, back to the lesson, please. Back to the lesson. We're here, yes? Okay. Can I translate this for you for a second? Is that okay? So I'm going to cover up everything after the comma, because the comma is just qualifying information for us, okay? So I'm covering up everything after the comma. What is that? So the way that functions are named, sometimes, not all the time, but sometimes, is where is the x? It's in the exponent, so guess what kind of function this is? An exponential function, okay? But wait, don't write it down yet. Watch how I write it down. Why did I move it way to the top? Because there's something else I need to write, and I need to leave some space for it. Okay? Something else I need to write, and I need to leave some space. No. We're not trying to guess right now. We'll figure it out in just a second. It's okay. This is the function. This is the qualifying statement. Okay? The function is f of x equals b to the x power. But we are specifying right now that b is greater than 1. So as a group, I would like us to decide what we want our b value to be. What's a number that's greater than 1? 2 is the most popular answer. Okay, so is that okay for us to use 2? So over here, we're going to go ahead and write b equals 2. So we all know what b we're talking about. Is it all right if we do table and graph first? Okay. Here's something you guys don't know. When the air conditioner comes on, I have a hard time hearing you because it's right over my head coming straight down. Okay? So if you're going to answer, I need you to answer a little bit louder this time. Is that fair? Okay? Thank you. Excellent. Okay. So yesterday we were kind of willy-nilly when it came to choosing values for x, right? Today we need to be a little bit more purposeful and have a reason for the numbers that we choose. You'll see why in a little bit, I think. Okay? So what did we choose for a value first yesterday? 0. So we can go ahead and choose 0 first. Let's go ahead and put it right here in the middle of the table. Why do we want to put it in the middle? So we can have negatives and positives. 0 is our starting point, but we want negatives and positives to help us see the whole picture of the graph if we can, right? Correct. Okay? So does anyone know what 2 to the 0 power is? Okay, it's 1. I need you to trust me on that for now. Okay? If you don't believe me, you can actually enter it into your calculator, 2 to the 0 power, and it'll tell you 1. But we don't need to do that right now. You can just believe me. Okay? When we get to exponentials, I promise you'll understand why. Okay? So 1, is 1 an okay number to choose? Do we know 2 to the first power? Because anything to the first power is just itself, right? So it's just 2. Is 2 an okay number to choose? 2 to the second power is what? 4, so that's pretty good, right? These may not be as good for you as far as knowing what they are, so I, for now, just need you to trust me on this. Is that okay? 2 to the negative 1/2 power is 1/2. 2 to the negative 2 power is 1/4. Again, when we get to the exponential chapter, to that unit, it will make sense. Because I've got a big visual that I show you to help it make sense, okay? It's okay if it doesn't make sense right now, for sure, okay? So let's go ahead and plot these points on this graph. Does yours look like mine? Okay. Can we connect them? How do you know? Is there another way to know that I didn't tell you yesterday because I wanted you to wait to know till today? What you got? So they are, but that doesn't automatically mean. So continuing and continuous don't mean the same thing. They sound like they do, right? To be fair, they sound like they do, but they really don't. But I can tell you this. If it says f of x, most of the time, not all the time, most of the time, it's a function and it's continuous. Okay? But you have to be careful because it's not true all the time. I hate telling you rules that are not true all the time because I don't want you to think I'm trying to trick you or something. Okay? This is continuous, yes, for sure. X-intercept. Okay, well, that's an intercept, right? But isn't that the y-intercept? Isn't that where it crosses the y-axis? 0, 1. Why would it not have one? It doesn't, does it? I, as a human, can't draw this because eventually the width of my pen and the width of the line on the paper, they're going to touch, right? But this is getting closer and closer to this axis and never, ever, ever touching it. Okay? That has a name, and it's one of my favorite math words, just for the record. Because the name of it is asymptote. Okay? So I like talking about asymptotes because I think they're funny. And I have lots of stories for you when we get to this chapter to talk about asymptotes, okay? But for now, just trust me that it's there. And it never touches. So is there an x-intercept? No. Okay, domain and range. You want to do that next? How far left does it go? And how far right does it go? So, all real, right? What about range? How far down does it go? It stops at 0, right? But does it get to 0? So how are we going to say that? Just greater than, right? Not greater than or equal, just greater than. Now we said it was continuous. We already took care of that. I just forgot to circle it. What about maximum and minimum? Remember, we're talking about a point, right? So what's the highest point? None. So what about the minimum? Does it ever get to 0? Okay. Because it's getting closer and closer to the asymptote, it doesn't ever cross anything, so there's not a minimum point either. It's getting closer and closer to 0. I want you to understand that, but there's not a minimum point. Okay? Intervals of increase and decrease. Some of you struggle with this today, so can I kind of teach it to you again? Maybe try in a different thing. Okay? I'm going to start drawing. I'm going to start on the left of the graph. Wherever the purple graph is, I'm going to start drawing. Am I increasing or am I decreasing? Am I increasing or am I decreasing? The whole way? So what's my interval of increase? Right? Everywhere it was increasing. Never did one time did you say I was decreasing, right? So where's my decrease then? None. So if you're struggling with that a little bit, start wherever your graph is. Start drawing. On the far left side that you can. Start drawing. Am I increasing or decreasing? Decreasing, decreasing, decreasing. Whoa. Increasing, increasing, increasing. So that should help you know where you're increasing and decreasing. Does that help? Okay. As we're moving to the left, where's it going? We are decreasing, but if we're talking about the end behavior, where's it going? But it is, isn't it? It's not going to infinity, is it? Because it's getting flatter and flatter, and it's getting closer and closer to 0. Will it ever get there? No, but it's going to 0. It's going toward the 0. Does that make sense? Okay. So what about this one? As it's moving to the right, where's it going? Up. That's definitely up, so that's definitely infinity. Okay? Questions? This one? For sure. As we're moving to the left, right, we're saying as our x's are moving to the left, what's happening to the graph? Well, it is decreasing, but it's not going down like it would be going to infinity. It's decreasing and getting closer and closer to 0, so we say it's going toward 0. Okay?
You would only write negative infinity if it was actually in a long and straight like that.
Yep, for sure. For sure. All right, what's next? The one right above it? You positive you want to do that one? Oh, wait. Oh, time out. We have to finish this one. We're not quite done. Sorry, I forgot about it. It's right here. Remember I told you there was a space? As we're moving from left to right, what is this graph doing? It is increasing. That's exactly right. It has a specific name, and it's called exponential growth. Okay? .10:33, so I have to finish at 31. Okay, so we have 3 minutes. 3 minutes. So this one you want me to start on? Okay, what's it called? That's close. Yep. I don't know why this is called exponential growth and exponential decay. Maybe somebody in the forensics field named it. I don't know. Okay. This is the qualifier. It's still the same equation. That's what gets some people confused, because these two are the same equations, right? It's only the qualifier that makes it different. This qualifier says the number has to be between 0 and 1. And a lot of people mistakenly say, oh, well, b is always a fraction. Well, except 4/3 is a fraction, isn't it? And is 4/3 between 0 and 1? No, so just be careful of that. What do you think the most popular answer is when I say choose a b value? Yep. We're going to say 1/2. Because it most often shows up as a fraction instead of a decimal. I know and you know that 1/2 is the same as 0.5. Okay? But we're going to say 0.5. Table. Again, we're choosing our numbers wisely. And this is another time where you're just going to have to trust me for now. If you don't understand what I'm saying, please trust that it's true. Okay? Is it okay to choose 0, you think? 0? Anything to the 0 power I told you a minute ago was what? 1. Okay? Is it okay to choose 1, you think? 1/2 to the 1 power is just 1/2. What about 2? So 1/2, remember when I square something, I square the numerator and square the denominator. Okay? So this is where it always gets tricky once we go into the negatives. Please believe that's true. Okay? Go ahead and plot those points. Can I connect them? Yeah. What's my x-intercept? What's my y-intercept? 0, 1. I really feel like I need to show you something on the other side. Can I do that real fast? Can you finish this on your own? Okay. Here's where I was talking about earlier. You want me to do top or bottom? Bottom? Okay. What's this called, do you think? What's this called? What's this called? Square root, right? So what's this called? Cube root. This is what I was talking about choosing our numbers better, wiser. Okay? If I'm choosing numbers to put in here, I want to choose easy ones to get out, right? Can I choose 0? Yes. Do you know what a cube root is, first of all? Okay, think about this. Tell me a number that you know the square root of. 4. We know the square root of 4 because it's 2 times 2. It's two numbers that are the same that multiply together that give me 4, right? So a cube root is the same thing, except there's just 3. What times what gives me that number? So a number that I know that's a cube is 8. Because what times what gives me 8? 2, right? Okay? So for my x values, I want to choose numbers like 1. And I want to choose numbers like 8. I don't want to choose 3. I don't want to choose 4 because I don't know the cube root of that number. I know the cube root of 0 is 0 because 0 times 0 times 0 is 0. I know the cube root of 1 is 1, and I know the cube root of 8 is 2. Do I know the cube root of negative 1? You can do it. You can do it. Okay? Finish the ones that we didn't together and have an awesome day. Peace.